Today on Inevitable, our guest is Jake Jurowitz, co-founder and CEO of Blue Energy. Blue Energy is a nuclear power plant developer. It starts with proven light water reactors and builds everything around them, prefabricating standardized nuclear plants as massive modules in shipyards and fab yards, and then barging them to site. It pairs that with a patented gas-to-nuclear approach that energizes the plant on gas turbines first and converts to nuclear later. The goal behind all of it is to make nuclear cheap enough and fast enough to build that private lenders will finance it, rather than the taxpayers and ratepayers who've carried almost every plant built so far. The company recently announced a collaboration with GE Vernova on a 2.5 gigawatt gas plus nuclear project in Texas, built around GE Vernova Hitachi's BWRX-300 reactor. Its backers include VXI Capital, @One Ventures, and Engine Ventures. The why now is straightforward. AI data centers are pulling on the grid harder than anything in a generation, firm, clean power is scarce, and the cost and speed of building nuclear have been the thing holding it back. Jake's bet is that the fix lives in how you build and finance the plant rather than in the reactor itself. From MCJ, I'm Cody Sims, and this is Inevitable. Climate change is inevitable. It's already here. But so are the solutions shaping our future. Join us every week to learn from experts and entrepreneurs about the transition of energy and industry. Jake, welcome to the show.
Thanks, Cody. Appreciate being on here.
Well, I'm glad we finally got a chance to meet. I've heard about you guys forever, and I feel like you're one of these companies that I keep seeing in the news, and yet you and I hadn't chatted. So here we are.
That's great to hear. For a while, I thought we were like kind of intentionally being sort of stealthy and silent. And now I'm trying to like tell our story a little bit more loudly. So I'm glad it's working.
Well, so I want to start with maybe a question that will be a little bit out there, but you have a line on your website that really jumped out to me, which was you said that Blue Energy is designing power plants that can be mass produced now in the world as it is, as a stepping stone to the world we want. And that really resonates with me, but I'm curious to hear you describe what you mean by that.
I should appreciate you pull that out because we're actually in the process of updating our website now. And I'm always sounding like, oh, like our website could be improved. So yeah, every word we put on there, we choose very carefully. The way that Blue Energy came to be, I've been in the nuclear space a long time. A lot of friends who have started or been a part of various nuclear startups and a lot of incumbent nuclear companies. They used to work for Exelon and Constellation for a long time. And what bugged me and why I felt like I had to start Blue Energy was it seems like there's two types of nuclear companies out there. 90% of them are type 1. They're trying to create a new reactor technology. And they say like the problems of nuclear power can be solved by inventing a wholly new reactor technology. And frankly, it puts you down a very expensive and very time-intensive journey to getting a minimum viable product. And then the other type of company is, oh, we just need to somehow persuade the government to just bite the bullet and fund this $100 billion endeavor of getting enough of these things built. We just need to build enough of them the way China has committed to it, a 100-year plan. And what bugs me is that kind of loses the thread of what's the root cause problem with nuclear. And the root cause is that the only thing holding it back is that it's too expensive to build and it takes too long to build. And no one seemed to be really focused on that core issue and innovating around that core issue. So what we're doing at Blue Energy is a little unique. We're a developer, but we have a technology and an IP and sort of a thesis around how to build the plant so that we can reduce the cost and schedule in a manner that allows us to project finance nuclear for the first time in history. And there's really two novel things that we're doing. One is that we're designing the whole plan, we're architecting it so that we can prefabricate it as big multi-thousand ton modules that can be barged into the site and prefabricated at shipyards and fab yards in the same style that big LNG or oil and gas projects have gotten built. And then the second is that we stumbled across this gas to nuclear technology that we've patented that allows us to build the nuclear balance of plant first and fire it early with 2 combustion turbines as a 2-on-1 combined cycle. And then we build the reactor next to it and splice in the steam and convert it from gas steam to nuclear steam. And that allows us to accelerate the schedule and reduce our cost of capital because we're paying a CCGT cost of capital instead of nuclear, first of kind nuclear cost of capital. These are the 2 tools we're using, but our focus as a company is purely on how to reduce cost and cost risk and schedule risk. We're not inventing a new reactor technology. We want to use the reactor technology available today.
So it sounds like thing one that you're doing, which we're going to dive into each of these and really unpack them, but thing one that you're doing, which is prefabbing the components modularly and being able to fit them on a barge and bring them over water to where you're building, is a unique, almost industrial throughput time to develop innovation. And then the gas to nuclear solution that you've talked about really is this idea that you can increase time to power by not waiting for the reactor itself to go through all of the regulatory approvals that need to happen. You can actually energize the site quickly and then cut over to nuclear once you're ready from a both regulatory and development perspective.
That's right. The core thesis of Blue Energy is modular prefabrication in shipyards and fab yards. The gas to nuclear was this opportunity we stumbled across as we started to develop this and solve problems. We try to be a really pragmatic organization that just addresses the problems as we see them.
While we build the world we want, the world we have would be taking advantage of, like you said, the gas to nuclear might be, hey, nuclear is a better, cleaner source of power, but it takes a long time to get it online. And so how do we leverage the things we have now to start energizing the site while we connect everything up? Is that the right way to think about it?
Yeah, one way I'd characterize it, because I think startup founders like to think in terms of minimum viable product, kind of ask yourself, what's the minimum viable product in nuclear? And rather than it being a $20 billion, giant, large nuclear plant, the world of small modular reactors came out, and those are still a few $billion. Then you saw the world of microreactors come out. And I think the microreactors really lean into like, what's the smallest nuclear reactor I can make, right? Smallest minimum viable product. But the problem with that is that it requires a lot of new technology and new licensing and a whole bunch of new permitting and regulatory risk you take on. And you have a lot of fixed costs and you don't have a lot of megawatts to amortize them over.
And nuclear is more efficient the larger it is, right? In terms of just generating reactions.
Yeah, the reality is there's real economies of scale in nuclear power that are just intrinsic to the technology and how we regulate it that you can't ignore. So there's sort of this question mark of, all right, where's the right sweet spot to be where you want to reduce the total absolute cap cost so you have a smaller minimum viable product to finance? Because you have to go and persuade a bunch of investors to pay for the first one. It's the first of a kind challenge that every climate technology has. And where I was really inspired was a startup called Venture Global LNG, who I think was really brilliant in the way that they were able to leverage lower cost of capital and project finance a first of a kind project through a really clever means. And the way they did it was through large modular prefabrication and fixed price contracting. So it's the combination of these things that made us realize if we do gas to nuclear, we can get half the nuclear plant built using the gas turbines. So now we have half a nuclear plant that exists in the real world. And now the minimum viable product is smaller. It's just the nuclear reactor. And we don't have to invent a new nuclear reactor. We can use a light water small modular reactor to get started.
Let's be really clear on that part. I think, as I understand it, you are not a reactor technology company at all. You are planning to use other people's reactors. You are buying the reactors and installing them into your power plants. Is that right?
That is totally right. We are not a reactor OEM. We're not designing a new reactor. It's public now. We're partnering with GE Vernova and GE Vernova Hitachi with the Betabricks 300, but we engage other reactor vendors as well.
Which would be a 300 megawatt reactor?
300 megawatt reactor. Right now, it's sort of a minimum viable product in terms of it's the most de-risked reactor technology that's ready to go. It runs on existing fuel, known supply chain, known capacity factor, known operations and maintenance costs. The only thing we got to work on is reducing cost of capital, bringing certainty to the construction of it.
Let's sort of pick apart each of these two big areas where you're driving innovation. Let's maybe start with the fabrication solution that you're developing and why. I assume it's in the name, Blue Energy, in terms of being sort of an ocean born solution, what that looks like.
Yeah, so the name Blue Energy is a funny conversation. I think one of the hardest branding challenges is how to name a nuclear startup, because you can kind of go a few different directions. You can either go really aggressive and really bold with some Greek name that I think maybe doesn't appreciate some of the history of NIMBYism and some nuclear concerns that we've had over the last 70 years.
Either Greek names or Tolkien names, the answer to everything.
That's right. So we were like, all right, let's try and be a little bit more inclusive, because I think to the phrase of we want to unlock the future we want, like going forward, I'm a believer that nuclear can have a much larger role in the global energy system and as a core technology for unlocking the next kind of tier of the global economy. And in order to do that, it means you have to have the social license to build a lot of nuclear plants. So as much as we're solving the technical problems, we also want to build a lot of respect, appreciation, brand, and trust with the communities that we work with, the public, with not just the US, but multiple nations, so we can put nuclear in all the places it's really needed. So the name Blue Energy is a few things. Yes, blue, it comes from the water. Everything we do is prefabbed and barged into the site. So that's really core to our strategy and our thesis and our technology. Blue also comes from, I think it's the misnomer. Everybody thinks that when they think of nuclear, they think of The Simpsons and they think of a green glowing nuclear waste. And that always bugged me, because if you go into a nuclear reactor, it's blue. It's Cherenkov radiation. It glows this really beautiful shade of blue. So just wanted to put it in the name. And actually, it's where our logo comes from. Those three circles is actually visualization of Cherenkov radiation. It's right up front. We're nuclear, we're blue. It also happens to be the color of the Scottish flag, which I think is a fun detail because we started the company with some Scottish heritage.
Awesome. So talking about the inspiration from the LNG world to fab and barge things in, describe that inspiration and what you are doing with it.
Yeah, so I was part of a research group at MIT over a decade ago that looked at this concept of shipyard manufacturing applied to nuclear fission. And it's actually an old idea that dates back really to the origins of nuclear power itself. The nuclear reactor technology that has been powering 20% of the US for the last 70 years really originated in the US Navy with the USS Nautilus in the 1950s. And then there was actually a program where the US Army Corps of Engineers built a floating nuclear powered barge that was called the MH-1A reactor that powered the Panama Canal during the 1960s. There was a joint venture between Westinghouse and Newport News Shipbuilding to prefabricate floating nuclear plants down in Jacksonville, Florida. They were going to build them in a shipyard and float them up the East Coast to Pisag in New Jersey. It actually got licensed in 1982. It's the only manufacturing license the NRC has ever issued. And then it kind of went dormant for a while because we didn't see a lot of load growth. We weren't really building new capacity, let alone new nuclear power plants for multiple decades. And then it kind of got reinvigorated by a few different startups, and MIT looked at this concept. So it's been this idea that's been around a while.
Though it was never serving a substantial portion of baseload power in the US, right? Like it's an idea, but it certainly didn't translate into the large gigawatt scale plants that are online in the US today.
Well, yeah, to be clear, nuclear has represented a large portion of the US grid, about 20%. But this idea of shipyard manufactured nuclear never really left the US Navy. Obviously, it's how we build our nuclear subs and our nuclear aircraft carriers, but it's never made the jump to commercial applications, commercial nuclear power. And now there's been these different ideas. You've seen a few other startups pursue this, like Thorcon and Seaboard, a few others in Europe. The Russians actually have deployed the first floating nuclear power plant. There's been these efforts to look at it in the last 10, 15 years. But what really inspired what we're doing at Blue Energy was seeing the success on how LNG export terminals got built. So I mentioned the startup Venture Global. I think they were a really interesting case study on how energy startups can succeed in scaling up in a way that's globally impactful.
Can you describe that for us?
Yeah. So what they did was they really kind of disrupted the way LNG export terminals were built. And it's very analogous to the challenges that nuclear power face. LNG export terminals were these big, multi-billion-dollar monolithic civil infrastructure projects where you bring in a big EPC like Bechtel. You'd have to go get a federal permit from FERC to be able to get the permission to liquefy and then export natural gas. There are huge engineering construction projects, required thousands and thousands of workers on site, sometimes for 10 years or so, and frequently were over cost and behind schedule. What they came up with is they re-architected an LNG export terminal to break it up into small modular trains where they could actually build and start to produce LNG while they were still building. The rest of the trains were building out the campus and the facility. And they designed it to be entirely prefabricated at an existing oil and gas fab yards. So large sections of this plant, and on the order of 2,000 tons, with full mechanical, electrical, plumbing outfitted, were being prefabbed and then barged in to these operating sites. And you could see some of their first projects down in Louisiana. And it cut the time in half for building their terminal. It surprised everybody how cost effective and how on schedule they were. And it allowed them, even as a startup, it allowed them to project finance their first project at 70% debt and dramatically lowered their cost of capital. And now they've been able to scale this up. I think they've done over 35 billion now in project finance, and I think are about to become larger than Qatar in terms of LNG export. Wow. They IPO'd over a year ago. Every climate startup, its ambitions should be to achieve global scale. It might be a good idea, but if you can't scale it, which means can you capture low cost of capital, which really means how do you tap into debt markets? How can you get the lowest cost of capital? Because that is what is required to build the magnitude of energy infrastructure that we need. You have to have a plan on how to do that. And their plan was the best evidence I'd seen of execution using this modular shipyard, fab yard prefabrication model, and seeing it work well in LNG really resonated and made me realize I think this could really help unlock the small modular reactor space.
And so now describe what you all are building at the shipyard and what it ultimately looks like at a port.
Limited to ports in terms of sites, but it does affect the sites that we choose because we have to pick sites where we can barge in big 1,000-ton modules to that site. So that means it's not just the coastline. We can get up the Mississippi River, the Missouri River, the Illinois River, the Ohio River, Tennessee River, up into the Great Lakes. We can really reach most sites east of the Rockies, which is where there's a lot of generation capacity requirement right now. The way that we're doing this is we're taking a plant architecture that's pretty mature, well-designed, and we're working with a number of fab yards, EPCs, and other kind of supply chain partners. In addition, GE Vernova, who's our OEM partner on this. And we're consolidating it into, as opposed to the truck-sized modules, which is when you hear the term small modular reactor,
yeah,
it's in the name. Everyone says they're going to be modular. But what that usually means today is you're limited to what can fit on the back of an 18-wheeler, which is maybe 40 tons.
Which is limited by, bridges and tunnels on the U.S. interstate highway system, right?
Exactly. You're limited by practical logistics. So you're trying to reach a total addressable market of everywhere, which means you're trying to design something that a truck can get to anywhere. That oftentimes limits you to just doing steel structural work. You're not usually pre-outfitting it with any mechanical, electrical equipment, plumbing systems. So you're not going as far as what oil and gas guys do in the offshore context, where they're basically just building a fully functional block that you can actually test at the fab yard because it's just big enough where you can actually get a fully functional subsystem going. And that's what we're doing is instead of constraining ourselves to what fits on the back of trucks, we're organizing these modules into what's the biggest thing we can barge to our site, which is like what can fit through an Army Corps of Engineers lock, like through the lock systems up the Mississippi River. So substantially larger. And that gets us to these big functional blocks where we can pre-outfit a lot of the equipment so we can move more of the scope of work off site. It gets it more under a fixed price contract, lower cost of labor. We're able to diversify and even parallelize the supply chain a little bit. It shrinks the amount of construction work that has to happen on site. And then we barge in these very large modules and we roll them off with these things called SPMTs, which is what the shipyard and oil and gas industry uses to move arbitrarily large and heavy things. They kind of look like what moves the space shuttle, like these big multi-axle robots. I kind of call them like industrial Roombas because you can daisy chain as many of them together as you want. And they jack it up and they roll it off the barge onto a quayside and we roll it onto the site and we'll set it down.
Do you build those robots yourselves?
No, those are available. These exist and it's attractive that way because if one of them breaks, you just pull it aside and put a new robot in place.
All right. So this is not the school of Elon where you're building every possible components to the thing you're building.
I think part of the challenge of getting nuclear done fast and on time is being very intentional about which risks we take on and which risks we don't take on. So we are looking at places where it makes sense to vertically integrate, where there's gaps in the market or where the supply chain might be underperforming. But by and large, we're able to tap into a lot of the existing supply chain and methods from the existing oil and gas industry, and we're just translating it over to nuclear for the first time.
So the power plant itself then doesn't live perpetually in a floating capacity. You ship it in and then you bring it sort of directly onshore.
That's right. So we ship it in via the water. Our sites don't have to literally be on the water. They can be a little bit off the water, but logistically, it has to be practical or feasible to roll it off the barge over to the site. So that's why we're not limited to ports by any means.
And what are the components you're building versus hiring out for? So let's describe the power plant itself. You said the reactor itself you're buying from an OEM, in this case Hitachi, or in the shorter term, and we'll get into your gas to nuclear pathway, but you've got to deal with GE Vernova on the gas turbine side. So that is a component that's showing up on site. I don't think that necessarily needs to go through the ocean-borne delivery to get there, or maybe it does. But what are you directly building on the power plants outside of the actual power gen engine?
Yeah, so the gas turbines come from GE Vernova. The reactor equipment, the nuclear side of the equipment comes from GE Vernova, Hitachi. There are actually even parts of the gas turbine we're looking at modularizing in a larger scale than is normally done. So there's things that are done in marine gas turbines with prefab and modularization that aren't normally done for large industrial scale power gas turbines that we're translating over. And that helps us reduce cost, reduce risk, expedite schedule. Most of the novel stuff we're doing, though, is on the nuclear side. And it's particularly in the reactor building and how we modularize that. So some of the things that we are looking at, and this is a combined effort of using existing supply chain and existing fab yards, working with particularly some of the fab yards down in South Texas that we've been really closely engaged with.
Just to be clear, this is like the containment, the cooling, the heat exchange, like those components?
Yeah, so the anatomy of a nuclear plant, you can kind of break it into two halves. There's the nuclear steam turbine hall, sometimes broadly called the balance of plant, which is the thing that converts steam into electricity. And then there's the reactor building or the nuclear island, which is the reactor vessel itself where the fuel resides and produces heat and steam. And then the containment vessel that sits around that, the safety systems, isolation condensers, and the civil structure. One of those things that is like Peter Thiel has this saying, like when you're trying to innovate, what's that truth that is very few people know about? And for me, I think that truth that very few people know about is that everyone knows nuclear power is really expensive. But when you double click on where the cost is in a nuclear plant, it's not actually in the reactor equipment. The reactor pressure vessel is not that expensive. All the equipment is really not that expensive. And nuclear represents less than 7% of the cost of the project. Most of the cost in nuclear construction is the civil structure and the cost of labor and the construction overhead of how to manage building that civil structure. It's the same reason the Denver International Airport was so expensive to build. It's just a huge multi-thousand person construction exercise. So that's the thing we're disrupting and we're focused on driving cost out of. So we're mostly looking at innovative ways of building that civil structure that encapsulates the reactor pressure vessel, that makes up the containment vessel, where those safety grade systems reside, how that thing interfaces with the earth, which is where your kind of earth moving subcontractor interfaces with your first nuclear grade systems going down into the ground. That's where the headaches have been at Vogtle and at traditional nuclear projects. And that's where we're borrowing a lot of lessons from shipbuilding and from oil and gas and from LNG and how to prefab those things. And the novel things to do there is it's fairly straightforward to prefab those things at the fab yards and the shipyards. The challenge is you have to have picked a site and done your whole development exercise with the intent of barging them in and moving them with these big robots and then lifting them and placing them into their final resting location while in the context of the Nuclear Regulatory Commission and all the licensing requirements involved. So one of the novel things we've done is we've gotten a topical report approved by the Nuclear Regulatory Commission on our gas to nuclear approach, which allows us to build a full balance of plant, that nuclear steam turbine early, even without a nuclear construction permit in place, energize it, even turn it on and operate, commission it with those gas turbines, and then later switch it to nuclear steam, which allows us to completely resequence the way we build the plant, changes the way we finance the plant, changes the risk profile. But it also gets into the nitty gritty of how do you handle maintenance rules, corrosion protection, like the commissioning and transition from gas steam to nuclear steam and all the conditions required for nuclear operations.
In the late 1990s, I owned a 1985 Toyota Land Cruiser, and it was a great car. It had, 200,000 plus miles. The engine died on it, and it was an underpowered straight six engine, and I put a heavy V8 in it. And I did that when I lived in Kansas. And then I moved to California, and I needed to get my car licensed. And California, from a smog perspective, couldn't even smog it, even though it was more efficient than the original straight six, because they looked under the hood and they're like, this engine shouldn't be in this car. We don't know how to do this. Denied. And I never could get that car smogged. I had to sell it for pennies on the dollar to some person who was a Toyota mechanic and knew how to deal with it. How do you not have that same thing happen to Blue Energy in the gas to nuclear conversion, where the NRC is like, how do we even understand this?
My first response is we have a really good licensing team based in DC. I really credit that team with the creativity and the thinking on how to approach this, because it's not just our balance of plant resequencing. There's a few other novel things we've done with top reports and re-engaging with the NRC and the White House and a number of other parties of the federal administration to really be very pragmatic and to accelerate schedules for permitting. So what it boils down to is what's nice about these new light water, passively safe small modular reactors that are, that GE Vernova, Hitachi has and that others have, is they've actually reduced the scope of safety grade components. So there's this really important classification in NRC space of what's related to safety, which is something that you count on when you go and you make your case for all these different events that could happen for nuclear safety. And then what's non-nuclear safety, which basically just means you have to assume that, Thanos snapped his fingers and that thing disappeared and you can't rely on it. What's nice about the passively safe reactors is that the entire balance of plant essentially is non-safety related. So we can confidently say, that distinction allows us to make a really detailed argument on why we should be able to build all these things that really don't affect the nuclear safety case, which is ultimately the NRC's responsibility. The reason for existing is maintaining nuclear safety to the public. There's a whole bunch of equipment we can build, including the entire balance of plant, that does not strictly pertain to that. So we can build it, we can energize it early. It's just steam turbines. And basically, the way we've made this argument is we're not skipping anything. We're still doing everything that would be required to commission and energize a nuclear power plant. We're just doing it out of order so we can build it and finance it faster.
What are the advantages of cutting to nuclear from gas? If you've got a multi-hundred megawatt gas plant up and running, generating power, you've got an offtake, you've got data center or whomever buying that power, why go through the extra cost of then upgrading it to nuclear?
That's like the existential question we were asking ourselves really early on when we came up with this idea. So to be very specific about what we're doing, we are going to build a 300 megawatt nuclear steam turbine, which is the BWRX 300 nuclear steam turbine. We're going to energize it with two 7HA Dowda 2 gas turbines, which are some of the biggest, newest, most modern, efficient gas turbines from GE Vernova. So it's actually over 1,000 megawatts that we're starting with as the CCGT. The reason you would do that, why then make the switch to nuclear? The reason is, and this is what our offtake partners are committed to, and the conversations that we're in with some of these hyperscalers who are strategically interested in nuclear and the utilities. The reason they need nuclear power isn't because it's clean. It is clean, and that's nice, and that's great to have. But it's because it's firm capacity that hedges their gas risk. They're building a ton of gas turbines right now to feed the AI growth. And you have to kind of recognize you're taking on a lot of gas commodity risk, a lot of gas supply risk. Next time there's a polar vortex that rips through the Midwest and takes out all of our gas supply, that's going to take out gigawatts of compute. You also have to recognize that there's emissions regulations risk, that administrations change and there's real risk to those gas turbines being ratcheted down in the future. You might not get the full useful life out of them. There's uncertainty there in regulatory space. Nuclear is that hedge. It's the best way to get firm capacity and to hedge all that risk. And that is why strategically where everyone's looking to procure nuclear power.
And are you structuring these as a full cutover, or does it become an and?
It's an and. Yeah, we're not throwing away the gas turbines. They're useful, valuable assets. So it's a little creative the way that we're doing it. The power contracts are structured in a different way, but essentially we're providing that gigawatt of gas capacity. We're then going to build just the reactor, switch over the steam, convert that steam turbine to nuclear steam. The gas turbines will switch to simple cycle mode temporarily. So we open up the bypass on the heat recovery steam generators. They operate in simple cycle mode. And then you've got a fully operating, de-risked, project financed small modular reactor. You've demonstrated how to build it. So then you can build SMR unit 2, 3, 4, et cetera, and deploy this to other sites. And you've got 2/3 of a modern H-class CCGT. So we also leave room for a second steam turbine that is fully optimized to be in combined cycle configuration. And that's to get the most efficiency and the most useful and value out of those gas turbines. That's the best way to do it.
The actual steam turbine, what you're using for gas is going to be a separate turbine from what you're using for nuclear. You're not sharing the actual turbine load across two different generation sources, or you are?
The nuclear steam turbine is first part of the CCGT and then later part of the nuclear plant. So it is a dual. There's others folks out there who have advertised, oh, we're doing gas as a bridge to nuclear. But really what they're doing is they're building gas and then next door they're building nuclear.
That's right.
What we're doing at Blue Energy is we're actually building half a nuclear plant on day one. And then we're splicing in gas turbines to bring it to life earlier. So there's a big hunk of asset that is dual use, that is being used by both facilities. And then we're switching it over to nuclear steam. And then we're disconnecting the gas turbines.
And then you'll reconnect the gas turbines to the next nuclear site, essentially?
It depends on the site. We actually have options on that. There's a design we have for doing the gas turbines on barges where we could have actually moved them and made them mobile. But for this first site, because we're using H classes, which are quite large, you could conceivably move them, but it would be more practical to leave them there and to just let them live out their life as a CCGT. So we're leaving room for a second steam turbines. There's actually optionality on what you do with them. You can leave them as simple cycle. You can convert them back to combined cycle. You could upend them and remove them. And people are actually doing that right now, which is pretty wild. You're seeing gas turbines get lifted and moved across the country. So there's optionality there. But the most efficient thing to do is to convert it back to a CCGT. But it is a different, to be clear, this is getting into technical wonkiness. A nuclear steam turbine is materially different than your standard steam turbine in a combined cycle natural gas plant. The casings are different. The pressures are different. There's superheat in the case of the gas. There's not superheat in the case of the nuclear. You actually get 70 more megawatts out of it when you build the more optimized steam turbine.
I see. Interesting. Talk about the initial site that you are building. Maybe describe as much as you can share about the location, the timing, the offtake, the size, et cetera.
Yeah, so we've got a number of sites around the country. There's one site we've announced publicly in the Port of Victoria, which we're very excited about, but there's still a lot of diligence we're working through before we would greenlight it for a final investment decision. But we're excited about the site, and it's a unique site for a few reasons. So it's about 30 miles inland from the Gulf Coast. Port of Victoria, for those who don't know where it is, it's roughly halfway between Houston and Corpus Christi, Texas. It's unique in that it's on a man-made canal that goes way inland, so we can barge everything in from the Intercoastal Waterway Network. It also happens to sit on a major transmission line for the area, and it happens to be very close to a project called the Victoria County Nuclear Station that Exelon was developing back in 2006, 2007 during the first nuclear renaissance. So it's a place where a lot of money went into nuclear development in the past, and the community has generally been very supportive of nuclear in that area. So it's unique in that respect. It's uniquely positioned to move relatively quickly to develop new nuclear capacity. We think it's a great place to demonstrate to the nation, to the world, this is a way to build nuclear on time and on budget that is surprisingly lower cost than what we've experienced before. It's a site we've partnered with Crusoe on, who's doing a data center development project next door to us, that it has the potential to be on the order of 1.5 gigawatts of load in that area. For our project, we'll actually have more generation capacity than that, because what we've learned as we toured sites around the Texas Gulf is it's a part of the country that even before AI and data centers, we needed a lot of generation capacity on the Texas coast because there's a lot of industrial load going in there. There's water desalination that's needed to help support the water in the area, which we're involved in. We're working on some water development in there to help bring water to the region. It's where there's a lot of battery factories, been a lot of reshoring of industry. A lot of the ports along the Texas Gulf needed more power. And we're also helping to bring an anchor customer in the form of the data center, which we think is also valuable and important. So we've had a lot of really good support from some key folks down in the area. We're optimistic about the community support, the value that this brings to that community. And we've gotten really positive engagement from a lot of folks who are looking at the project. And we're excited. Like I said, there's still a lot of work to do on it, but we're optimistic on the potential for it to move very quickly.
Having a named destination and named location certainly helps with a lot of the regulatory angles that we were talking about too, I would guess.
It does. The way licensing works in this country is you've got to submit a license for a particular point on the earth to get a license to build a nuclear plant. So we're lucky that it's a site where there's been a lot of data collected already. It helps us expedite that licensing and permitting process. We've been engaged with a number of the hyperscalers on the site. I think there's a lot of appetite for the power in that area.
It strikes me that, and you've sort of hinted at this, ultimately the real product you might be building, and this is not discounting the amount of incredible deep tech hardware work that your team is doing, but the real product you might be building is financial innovation, right? It's like figuring out a financing structure that has a power plant attached to it. Can you talk about why a project financier looks at blue energy differently than it might a conventional nuclear build?
Yeah, well, I'll make the argument here because I've been a part of the nuclear industry long enough where I've seen people make the argument, as I said at the beginning, that we need to invent a new technology and that's the solution. I've heard the argument of, oh, we just need developers to go out there and develop land for new nuclear, and that's the solution. I've heard the argument many times before, we just need financial engineering. Let's just financially innovate our way out of solving this. And the reality is that none of those by themselves are sufficient to solve the problem that nuclear has. Yes, you need to do site development. If you're going to put a power plant somewhere, you got to do site development. Yes, there's financial innovation that needs to happen because no one has ever project financed a nuclear plant before. Every nuclear plant that exists on Earth was built on the back of taxpayers and ratepayers. It's all been government financed because they're so prone to cost overrun risk and schedule delay. And that doesn't scale. That's not how we should be building infrastructure. It doesn't create the right incentives. That's not the way we should be doing it. The thing that is required is, yes, a little bit of financial innovation, but it's really innovation around how you do the build execution and how you think that affects site development and site selection. But it really affects the details and how you architect the plant for final design, final engineering execution. And it's been one of these things that's been ignored. 70% of the CapEx of a nuclear plant is not the OEM scope, it's the EPC scope. And EPCs haven't been building nuclear plants for a long time. So it's really thinking about the 70% of the problem of how we build it, how we assemble it. So like the simple analogy I like to use is normally when you try to build a power plant, or what banks want to see is they want to see one fixed price, lump sum wrapped contract from a construction firm on the whole project. What we're doing is we're breaking the project into multiple big Lego pieces. Each Lego piece has a fixed price contract from the fabricator shipyard. And then we're working with a construction partner to assemble those Lego pieces. And collectively, we can still go to the banks and debt finance it. And yes, there's some financial innovation there that's required, but it's been done in LNG and in offshore wind and other oil and gas projects. So there's precedent in adjacent industries.
And you did get some debt commitment as part of the last financing round that you raised. Maybe share a little bit there in terms of what you can disclose.
We did, yeah. I can't share all the details on it, but particularly because of how we're doing this gas to nuclear conversion, we were able to bring a really significant amount of equipment financing collateralized against equipment to help us actually put deposits down on ordering things like the gas turbines and some of the other long lead equipment. You can only do that if you're working with relatively de-risked Lego pieces. And it's helped us, I think, overcome some of these valleys of death that a lot of climate tech companies run into.
So put your own suit and tie on and sit on the other side of the table from yourself, from your past life when you worked in investing in nuclear. And what would be the one or two top sort of challenging questions you would give to Jake, the CEO?
Oh man, challenging questions. The challenging questions are the ones that we grapple with every day. We've been grappling with today especially, which is what are the details around where you break the plan up for the modules? How are you going to get towards fixed price contracts. That's been the missing piece, right? No construction firm has ever been willing to sign a fixed price contract on a nuclear build because they can't get their hands around mobilizing 10,000 nuclear grade welders in the field. Who is going to sign those fixed price contracts? We've got those folks lined up. We've been engaged with them. I think the other hard challenge is who's going to be that first creditworthy off-taker? Because naturally, the first one's always a little bit more expensive. Who's going to buy into that vision, that strategy on driving the cost down over time? We think we've set this up in such a way that we can most credibly show the learning curve and really put nuclear onto a learning curve for the first time, akin to wind, solar, and batteries. Who's going to take the plunge? Who's going to be your strategic partner for that first offtake and say, this is what I'm buying into? That's an important one. But there's other big ingredients here. I think, how are the utilities and IPPs going to engage on this? Because they're a really important piece of the equation for ultimately building out, getting the transmission connection, bringing capacity to the other states. What's the role that the government's going to have? How is the rest of the world going to look at this? The big question on my mind every day, even after we accomplish all this, is how's the public going to perceive nuclear longer term going forward? I'm a strong believer that once you've got a turnkey nuclear power product that is $5,000 a kilowatt or less, that can be project financed at 70, 80% debt. There's basically infinite demand for that. But it's getting more complicated to permit infrastructure, not just in the US, but all over the world.
And with nuclear, we've seen the movie before where one mistake on the other side of the world penalizes the whole industry substantially.
Yes. And believe me, that's something that's on my mind. I know it's on the mind of some of my former professors and some of the folks who've been in the nuclear industry their whole careers. There's a lot of excitement around the nuclear space right now. There's a lot of new entrants into the nuclear space. Some are doing things right. Some are doing things a little bit recklessly. And oftentimes you hear, particularly in Silicon Valley, what's beautiful about Silicon Valley is permissionless innovation. Like, you don't need anyone's permission to go and disrupt and create a software business. You didn't need permission to do Uber or Airbnb. Very famously, we kind of just went in, deployed it, and regulators caught up with it later. You can kind of get away with that in most industries. You can't really get away with that in the nuclear space. Nuclear is a place you need permissioned innovation.
It feels like you're building this solution that's modular and flexible, which has some early design advantages, but at some point you have to make hard choices in lots of directions to lock in design and scope. You don't just show up at the Port of Victoria with a bunch of Lego pieces and be a master builder and decide what you're going to build once they're all on shore, right? You had to choose to use the reactor technology that you're using. You didn't just say, oh, we'll just decide after the plant's up and running and figure out what we want to drop in.
That's right. We try to maintain optionality as long as we can, but when you're building and managing large capital infrastructure projects, you've got to pick dates that are your pencils down. And you've done as much as you can on this version of it. You've got to just move forward on executing. And then all the new ideas you come up with, put that into Mark II, Mark III, Mark IV as you deploy new units. So yeah, that's absolutely right. We were very thoughtful in how we chose our reactor vendor OEM. We engaged with a lot of different partners to make sure that we were partnering with the right team, and we think we have.
Let's look forward another 5 years or so. How does the world look different? What do you think the evolution of the nuclear space looks like, not just in your world with Blue Energy, but everything from what's happening in SMRs, everything that's happening in microreactors, everything that's happening in restarts of large-scale nuclear power plant projects, things that are happening with uprating. There's a lot going on in this space. What do you think the world looks like in 5 years?
It's been such a radical change in the last 4 years. From my time at Exelon, we were talking about shutting plants down, like Byron and Braidwood. We shut down 3 Mile Island. And now we're uprating Byron and Braidwood. And I've never seen a more radical, and I would just call it sort of a market failure, such a massive price dislocation where we went from these plants were apparently not cost competitive at $25 a megawatt hour. And now we're signing PPAs at $120 a megawatt hour for some of those same units.
Well, that's a question of how sustainable is that? That's an interesting observation for sure.
Yeah, I mean, I would argue that it's a failure of the capacity market and how we price capacity. I think we've misunderstood on how to price capacity accurately People always think in terms of megawatt hours because that's what you see on your retail bill as a customer. And that's just a convenient way to measure, but it's not actually what people buy. People don't buy megawatt hours. They buy instantaneous power. We expect to have as much power as we command instantaneously. And then we just kind of reverse engineer into a price per megawatt hour. And that's like the art of rate making as a utility. But what you're going to see is the lowest hanging fruit's going to get picked first. Uprates are going to happen. We're going to do as many uprates as we can across the nuclear fleet as it exists today. And there's plenty of potential there, but there's a limited potential. You can only squeeze so much juice out of these plants that exist. We're doing restarts at all the plants that make sense now. You've seen Palisades, 3 Mile Island, or the Crane Clean Energy Center, as it's now called, and the Duane Arnold plant with NextEra. You probably won't see that many more. I'd be surprised if you saw any more power uprates because there really are not that many more nuclear plants that were recently shut down that you could reasonably restart at a reasonable cost. And that's where we come in, is what's the next lowest risk way and fastest way to get net new nuclear capacity built. And then there's the Gen 4 conversation, which I think is really interesting. And there's some exciting technologies that are maturing there. And I can't wait for them to become commercialized because they open up new capabilities like high temperature heat, higher efficiencies, potentially closing the fuel cycle. There's a lot of novel things happening there. But in terms of what you can deploy today, it's the light water small modular reactor technology that is the lowest risk way to finance and put a scale on the ground with the supply chain as it is today. So I like the saying, everybody overestimates what's going to happen in 5 years and underestimates what's going to happen in 10. I think you're going to see a few of these Gen 4 sort of for like first of a kind prototype reactors start to come online or start to produce first power in the early 2030s. I think we're well positioned to get a fully commercial light water SMR built and operating as early as 2032. That's very real. And once we've demonstrated that, I think we'll surprise the market on how much demand there will be to build more.
How should we all view the upcoming July 4th criticality milestone? We're going to see, this episode may even ship after this date, I'm not sure, but we're going to see multiple SMRs declare victory on that. And I'm curious what you think that means.
I think there's a few cool research projects happening there. Not all criticality is not equivalent for everybody who's working on it. The hard part of a nuclear reactor isn't making it go critical. It's actually relatively easy to make fissile material go critical. The hard part is going critical in a way that is completely managed and controlled and safe and regulated for making commercial power in a way that's interconnected synchronously with the transmission system. And that is a very different bar than just going critical. I think we'll see the projects go critical. I think they're exciting for some of these new microreactors that have really interesting applications for off-grid power, defense, national security.
Antares already announced theirs, right? They announced it this week, I think.
I'm close with and friends with a lot of those companies. I'm excited for them. I think there'll be great milestones for them. There's still a big journey for de-risking. Some of those guys are also going after very different markets and use cases. As I said, like off-grid, space applications, defense applications. That's just a very different than grid-scale power.
Jake, I know we're running into time here for wrapping this up. Any last thoughts you want to share? Anywhere you need help? Anywhere motivated listeners should think about plugging in some way?
One of the things that has always kept me passionate about nuclear isn't just the energy and the climate conversation, but the national security and the energy security conversation, which I think is particularly relevant since Nord Stream 2 blew up with the war in Ukraine. And now that the Strait of Hormuz is closed. When you expand your lens outside the United States and you start to look at US allies, there's a lot of places where nuclear power is getting built, like Turkey and Egypt. Going to be places that Russia and China are going to start exporting nuclear power technology, if not for the US having some prepackaged project financeable nuclear power product. And I think it's strategically important for the West to develop that nuclear power product that we can readily export to Eastern Europe, the Middle East, Southeast Asia. Because in the absence of doing that, it will change the geopolitical landscape for the next 100 years or multiple 100 years. So that is where sometimes that narrative gets lost because we keep a very myopic lens on energy in the US and we lose track because energy is so much cheaper here than other parts of the world. Nuclear has a really important role to play. It's the only thing that can deliver turnkey energy security, energy sovereignty because you can stockpile so much energy because it's such a uniquely dense fuel source.
Thank you, Jake. Really appreciate you jumping on and sharing what you're up to. It's great to finally meet you, and it was awesome to hear more about what you're building at Blue Energy. I look forward to following along.
Thank you. Appreciate the time.
Inevitable is an MCJ podcast. At MCJ, we back founders driving the transition of energy and industry and solving the inevitable impacts of climate change. If you'd like to learn more about MCJ, visit us at mcj.vc and subscribe to our weekly newsletter at newsletter.mcj.vc. Thanks, and see you next episode.